The James Webb Space Telescope has upset cosmology in 2024, delivering discoveries that challenge our deepest understanding of the universe. From stunning images of distant galaxies to data that defies conventional theories, the telescope has uncovered anomalies in the early universe that suggest something extraordinary may have occurred even before the Big Bang. The telescope's observations of ancient light and distant galaxies have revealed inconsistencies that don't align with current hypotheses of cosmic evolution. Bizarre patterns in the early universe's structure, unexpected galaxy formations, and perplexing traces of pre-Big Bang conditions suggest that the universe's history may be far more complex than previously imagined. These revelations are not only expanding our knowledge, but they are also reshaping our understanding of the universe's origins. Hypothetical models, from inflationary theory to the idea of a single starting point, are being reconsidered. Scientists are now exploring possible outcomes, such as a repeating universe, hidden dimensions, or interactions with other universes in a multiverse framework. In this video, we will delve into these groundbreaking discoveries and examine how they challenge everything we thought we knew. Before diving into these astonishing revelations, it's important to first grasp the basics of what current theories tell us about the size, age, and origins of the universe. From here, we will establish a foundation to appreciate just how remarkable the James Webb Space Telescope's contributions have been in reshaping how we understand the universe. Let's embark on this journey to uncover how the James Webb Space Telescope is rewriting the story of the universe, past, present, and future. If you're in any doubt about how significant these new images are, I want to be in this room because around me are the researchers, the astrophysicists, the cosmologists who truly understand how they've changed our perspective on the universe. Such information in a fraction of the time we were previously accustomed to. Soon, some of the records we hold in the current universe will be shattered. They've said, well, what happened? What did you figure out that we didn't know before? And, of course, the big answers are, the first galaxies developed differently than we expected, and we don't know why their old predictions were wrong. It suggests that the universe has a progenitor, another universe. Think about this. When the Webb telescope looks as far into space as possible, it will only see about 46.5 billion light-years away. This is the range of our observable universe, which we call the Hubble radius or Hubble sphere. However, we know that our universe is expanding. This expansion isn't like objects moving outward into void space. It's the expansion of space itself. This idea can feel counterintuitive because there is no central point from which the universe is expanding. Instead, scientists understand that the expansion of space happens everywhere simultaneously, constantly stretching the distances between objects. If we consider this expansion, it will seem like everything in the universe is moving away from each other. But here a question arises. If everything in the universe is moving apart, why do we observe galaxies colliding? And why is the Andromeda galaxy moving toward the Milky Way rather than away? The answer lies in gravity. When the gravitational force between two objects is strong enough, it can overcome the expansion of space. Scientists have also observed that space is not only expanding, but it is accelerating, meaning distant galaxies are moving away from us at a faster rate than nearby galaxies. As we know, the farther a galaxy is, the faster it is receding from us. So when we look at distant galaxies, we see that in certain regions of space, some galaxies are receding from us at the speed of light. Scientists have named this region the Hubble sphere, and galaxies beyond the sphere are moving away from us at a speed greater than the speed of light. Common sense would suggest that we will never be able to see the light coming from those galaxies, because the light is moving away from us faster than the speed of light. But surprisingly, this isn't true. We can still see galaxies that exist beyond the Hubble sphere because the Hubble sphere is expanding due to the accelerated expansion of space. As this region grows, more distant galaxies come into view, even if they're receding from us faster than the speed of light. But there's a limit to how far we can see into the universe, and this limit is known as the observable universe. It spans around 93 billion light-years across. There are many more galaxies and stars beyond the observable universe, and we don't know how large the entire universe is. Most scientists believe the universe could be infinite in size. What's even more fascinating is that the limit of the observable universe depends on where you are. An alien civilization in a different galaxy would see an entirely different observable universe because they would have their own unique perspective. Now, the concept that makes our observable universe even stranger is that when we look at distant parts of the universe, we are actually looking back in time. We don't see those regions of space as they are now, but rather as they were in the past. This happens because light takes time to travel through space. For example, if we look at something 1 light year away, we're seeing it as it was 1 year ago. The farther we look, the further back in time we see. So far, scientists have observed more than 13 billion light years into the early universe using powerful telescopes, and with the help of these observations, they have constructed a standard model of our universe, which shows what the universe looked like at different time periods in the past. For example, if we looked more than 13 billion light years away, we would see the Dark Ages, a time when the entire universe was shrouded in clouds of hydrogen gas. According to the standard cosmological model, if we were to look all the way to the edge of our observable universe, about 13.8 billion light years away, we would see the very first moments of our universe, the Big Bang. Now, according to our standard cosmological model, which states that about 14 billion years ago, the entire observable universe and everything beyond it that we can't see would have been compressed into a tiny, infinite point we call the singularity. No, I actually mean that would be true if the universe were finite, but if the universe is infinite, and it kind of seems like it is, then it was always infinite. So, the Big Bang would have happened literally everywhere. This means that the first galaxies didn't form in a specific region of space. They formed everywhere in the universe. In fact, even beyond the observable universe that we can't see, perhaps matter came into existence everywhere in the universe at the same time. The cosmic microwave background radiation we see everywhere in the universe is the first light of matter coming from all directions in the universe. So, this is everything our theories tell us about the size of the universe and how it came into existence. However, the new discoveries from the James Webb Space Telescope are challenging all these theories and forcing us to rethink our understanding of the universe. We need to discuss all these astonishing discoveries one by one. Recently, scientists found a number of ancient, very massive black holes, which represents a significant challenge for astrophysicists. One of these black holes is so unusual that our theories completely fail to explain it. Scientists are claiming that this black hole may have formed before the Big Bang. In a paper published in Nature Astronomy, researchers reported the discovery of an ancient, very massive black hole, one that existed early in the history of the universe. While some enthusiasts have claimed that the observation of these massive black holes has disproven the Big Bang theory, our standard cosmological model, which is entirely based on observations and our physical theories, predicts that in the early universe, black holes were formed from the remnants of massive stars. When these stars ran out of nuclear fuel, gravity caused their cores to collapse, creating incredibly dense objects known as black holes. However, observations from the Webb telescope have revealed a more diverse collection. It has found several black holes that don't fit perfectly into the traditional story of stellar collapse. Some are surprisingly massive, challenging conventional views of stellar evolution. Astronomers were shocked when they found that the mass of this unusual black hole at the center of the ancient galaxy was about equal to the total mass of all the stars in that galaxy. To put this into perspective, the very massive black hole at the center of the Milky Way is only about 0.1% the mass of the entire galaxy. Given that this ancient, very massive black hole formed so quickly after the universe began, it couldn't have been made by the collapse of stars and the merging of stellar mass black holes. Instead, another mechanism is required. Complex simulations have shown that early in the history of the universe, it's possible for giant clouds of gas to have collapsed directly into extremely massive black holes, ones with masses several times that of the Sun. The James Webb Space Telescope has found more of these ancient, very massive black holes. At the actual edge of our recognizable universe, this demonstrates that the direct breakdown of residue mist in the early universe wouldn't be sufficient to make sense of this mystery. Yet, stand by! Researchers at the KVI Foundation for Physical Science and Science of the Universe have made an astounding finding that shows these dark openings might have formed in a child universe. One exciting possibility is that early-stage dark openings could form from the child universes made during expansion, a time of fast extension that is believed to be responsible for cultivating the structures we observe today, such as galaxies and groups of galaxies. During expansion, child universes can branch off of our universe. A little child or daughter universe would eventually fall, but the enormous amount of energy released in the small volume creates a dark opening. In simpler terms, it expresses that previously, before the Big Bang, child universes impacted with our universe, and these crashes made early-stage dark openings in the early universe. Here is evidence that supports this claim. Roughly 10 years ago, Nobel laureate Dr. Roger Penrose has been promoting incredibly controversial claims that the universe shows evidence of a variety of features that are consistent with our universe impacting with and being wounded by what happened preceding the Big Bang. This theory completely makes sense of how supermassive black holes formed in the early universe. Early-stage black holes could be responsible for some of the observed gravitational wave signals and seed the very large black holes found at the center of early galaxies discovered by the James Webb Telescope. Notwithstanding that, the group speculated that early-stage black holes could also play a role in the union of heavy elements. This theory could explain the unexpected heavy elements seen in Webb Telescope's observations of early universes. So, these new Webb discoveries suggest that early-stage black holes were made by the collision of child universes with our own. This early-stage black hole hypothesis perfectly explains the unexpected discoveries of the James Webb Telescope. Our standard cosmological model is also wrong. Later on, when researchers looked at the new observational data, they were staggered. No one expected that we would see something like this. Researchers saw that numerous early galaxies beyond the edge of the early universe suddenly appeared in this data. One of these galaxies has a redshift of around 17, which is unthinkable according to our current models. Well, recent observations have shown that this galaxy was actually a sham. Among these far-off galaxies, spectroscopy data revealed that this galaxy actually had a redshift value of 5. The residue cloud arranged between the Webb telescope and this system made the galaxy appear incredibly far away, almost like a distant divine object. Peter Van Dome, an astronomer at Yale College, not involved in the latest research, said that the Webb telescope has noticed potential galaxies much closer to the Big Bang, but they still haven't been confirmed. Anyway, some of the candidate galaxies, if confirmed, would have existed when the universe was under 200 million years old. Researchers express aloud that whatever this data is showing is actually a big issue for our standard cosmological model. This gigantic population of galaxies close to the Big Bang raises more questions for us to solve. Ongoing observations have revealed something startling in the early universe, testing researchers worldwide and suggesting that what the Webb telescope found might be a significant issue for our standard model. In an extraordinary discovery, space experts have identified a strange structure found deep in the early universe. The revelation has perplexed researchers as it challenges how we might interpret astronomical beginnings. At this moment, space experts don't know what this weird structure is, and what is especially astounding is that it has been considered much older than the Big Bang. In a recently published research paper, researchers have advanced 3 possible explanations for this unconventional structure. They've carefully analyzed each possibility and concluded that the first 2 are unlikely, while the third appears to be the most plausible. However, they warn that if the third explanation turns out to be true, it could signal the first major change in the field of cosmology. In the paper, Researchers revealed that this object could be a galaxy with observational properties, like the little red spots recently found by the James Webb Telescope. Yet researchers saw that this red galaxy is situated at a redshift of Z, equivalent to 15, indicating that it existed just 100 million years after the Big Bang. If this third explanation is correct, it would be the oldest and most distant known galaxy ever observed. Well, the discovery of these small red dot galaxies has already been a major headache for researchers because these galaxies are much more massive and bright than our models predict. And now, we've found another object much farther away, one that could completely break the standard cosmological model. This discovery presents a huge challenge to our current understanding of the universe. According to ordinary cosmological standards, galaxies shouldn't form so early. Let's consider this. One of the main pillars of cosmology is that the spatial distribution of matter in the universe is consistently isotropic. This means that everything appears the same in all directions if you look at large enough distances. This is clear since the forces are supposed to act uniformly throughout the universe on a large scale. Furthermore, it should create no noticeable imbalances in the large-scale organization of matter that was originally set by the Big Bang. Wherever you look, you'll find the same density of matter, the same temperature, and the universe is expanding equally everywhere. For over a long period, researchers have been developing different cosmological models based on the assumption that our universe is uniform in all directions. The Big Bang model, which is the best theory to understand the universe, is also based on this assumption. The cosmic microwave background radiation also shows that the universe is the same everywhere. Yet a recent study, published February 6th in the Astrophysical Journal Letters, suggests that there might be something truly wrong with this assumption. Recently, space experts have confirmed that the rate of expansion of our universe is not the same everywhere. In this paper, they revealed that depending on where we look, the universe is expanding at different rates. Well, this is a major issue now because if the universe is growing at different rates in different places, it will create a significant problem for space experts. This new study also suggests that we might be completely wrong about the current estimated age and nature of our universe. David Gross, a Nobel Prize-winning space expert, said that we wouldn't consider it a pressure or issue but rather an emergency. New pictures from the James Webb Telescope confirm that the previous measurements were correct and the universe is expanding differently in different places. This discrepancy in the value of the expansion rate of the universe suggests that maybe the universe is not the same everywhere. Well, if this is true, then our standard cosmological model would fall apart because we can't estimate the age and size of our universe with different expansion rates. The most significant question that will emerge is the justification for the universe expanding differently at various places. One charming explanation could be dark energy, the mysterious force that seems to be driving the acceleration of the universe's expansion is itself not uniform. As such, dark energy is stronger in certain parts of the universe than others, causing different expansion rates. Researchers claim that if the universe isn't homogeneous and isotropic, it would mean that the very laws as we understand them are difficult to comprehend. Right over the cosmological horizon, the force of gravity could act backward. The speed of light may be slower than walking speed, and unicorns could be real. Well, this new discovery from the Webb telescope has sparked an extraordinary debate among space experts. This is because the non-uniform expansion of the universe challenges the cosmological principle, and it is one of the cornerstones of space science. The James Webb Telescope again found an ultra-high redshifted universe that broke all of our speculations. Researchers have just found F200 DB45, a candidate high redshift galaxy with an expected redshift of around the equivalent to 20.4, relating to 168 million years after the Big Bang. If confirmed, it would be one of the earliest and most distant known galaxies ever observed. Well, This galaxy is still one of the most distant candidates and must go through many tests to get confirmation. But if confirmed, the standard model would need to be updated again to get a better estimated age of the universe. The galaxy, the T-scope, found at Z equivalent to 14.32%. Conditions for life were available nearly from the beginning of recorded history. The presence of oxygen, right off the bat in the existence of the system, is a shock and proposes that different ages of extremely gigantic stars had proactively carried on with their lives before we noticed the system. All of these perceptions together let us know that JAGE GSZ14 isn't similar to the kinds of systems that have been anticipated by hypothetical models and virtual experiences to exist in the early universe. With all this information, researchers are presently claiming that the James Webb Telescope will soon notice cosmic systems from when the universe was extremely youthful at a redshift of 20. This means thinking back to when the universe was only a couple 100 million years old. Anyway, they are concerned that if the telescope sees much more distant cosmic systems, this could challenge how we might interpret how cosmic systems form, as indicated by our norm cosmological model. There is a limitation to our universe, beyond which we can't see anything. It is called the Dark Age. Following the Big Bang, the universe entered a period known as the Dull Ages. During this time, the universe was filled with neutral hydrogen gas, and there were no stars or worlds to transmit light, making it murky and dull. Up until this point, all that we know about the universe beyond the Dark Ages is simply theory. No one truly understands what lies beyond it. Shockingly, new pictures from the James Webb Telescope have uncovered systems that existed even before what we call the dark times of the universe. This discovery is confusing researchers, as it's muddled how these cosmic systems could have formed so early. What's even more astounding is that these old systems seem to be the systems we see from the early universe. These discoveries bring up a significant issue. Might we be taking a look at a totally different universe? Why do we continue to view giant and mature universes as we look further into the universe? If our physics is right, we should see little and youthful universes as we look further into the early universe, and there should be no worlds or stars after a certain distance. Yet, as the Webb telescope looked into the early universe and then some, finding an increasing number of gigantic universes, it seemed we were looking at an alternate universe with different laws of physics. Here's a universe called Burns 2112, as seen by the Webb telescope a couple of million years after the Big Bang. Researchers say that the size of this world is practically like our universe. The presence of such worlds, like our Milky Way, only a few million years later after the Big Bang, presents a significant issue for our standard cosmological model. Cosmologists thought barred spiral galaxies, for example, the Milky Way, didn't show up until the universe reached at least 50% of its current age, since it was believed that it took several billion years of cosmic development for the gigantic assortments of stars within a galaxy to form. Central bars in galaxies were recently thought to mark the end of a galaxy's early stages, so they were expected to be seen exclusively in old galaxies that might have reached complete development, perhaps those that existed midway through the development of the universe. Indeed, the Hubble Space Telescope's past observations of galaxy morphologies have shown that the early universe hosted very few barred galaxies. However, the new discoveries gathered from information by the James Webb Space Telescope suggest it may not be as evident that barred galaxies wandered the universe for such a long time. The discovery of Burns 2112 uncovers systems that look like our own, and they existed as far back as 11.7 billion years ago, when the universe had just 15% of its life. Over billions of years, galaxies went through striking changes through processes like mergers, crashes, and the formation of new stars. This advancement, seen through telescopes, shows how galaxies have changed in size, shape, and organization. The fascinating perspective is simply this: development isn't just random, it's a consistent educational experience. Yet, The discovery of Burns 2112 has suggested that this development required only around 1 billion years or less. The existence of these incredibly old universe candidates, like the Milky Way, only a couple of billion years after the Big Bang, presents a serious challenge to our theories. Are we missing something in our galaxy formation models? Or are we completely wrong about the early universe and its beginnings? If you have watched this video fully, then please share your thoughts in the comments. Thank you for finding something new. It doesn't create an issue as much as it creates excitement, another understanding of the universe we enjoy. It's not like we all are sitting back with our definitive answers over the table, lounging in the knowledge of the universe that we have control over. No, we are always at the planning stage, and to the people who say researchers should go back to the planning stage, we're always there. If you're an active research scientist, that's where you live, and you're bewildered every day. Plus, of course, the universe is full of mysteries.